Hey everyone, so today you are going to work on student book page 7 and it is called Are They Equivalent? Now remember that equivalent word, it has equal in it. And we know that equal also means the same. Okay, so I always like to think of like a teeter-totter. And is this side of the teeter-totter, is it the same as the other side? Okay, so looking at this problem or this assignment, number 1 says mark each of the following equations true or false. So it also says tell how you know. What you'll be doing is using that equal sign or that same as sign. So is this side the same value as this side? You could do it a couple different ways. Yes, of course, you could say, well, what is 12 times 6? And is that the same as 24 times 3? If these two are the same, yeah, A would be equivalent. It would be true. Yes, it would be equivalent. However, you could also do it another way. You could think about something called number relationships. So a number relationship is how numbers on one side of the equal sign are the same or equal, possibly, to the other side. So, for example, you had 12 times 6. How did those numbers or those factors connect to the factors 24 times 3? Well, if we're looking at these, do you see a relationship? Does 12 connect to 24? Does 12 connect to 3? Does 6 connect to 24? Or does 6 connect to 3? Okay, when I'm looking at this, I see that, well, 12 does connect to 24. In fact, 12 is half of 24. So in order to get from 12 to 24, I doubled it, right? But then looking at here to 6 to 3, I didn't double, I halved it. Well, those connect to each other, don't they? They have a relationship, right? Doubling and halving. And we worked on that relationship of doubling and halving in our problem string. Apparently, I can't spell, guys and gals. Doubling and halving. So look at those number relationships. How do the numbers or the factors on one side of the equal sign connect to the factors on the other? And can you use that to see if those products are similar? Now, for number two, it says fill in the blank to make each equation true. So we're going to try and use those number relationships. How do the factors on this side of the equals or same as sign connect to the factors over here? Well, 6, does 6 connect to 3, or does it connect to 14? Well, I know 6 chopped in half is 3. So knowing that, how could you use those number relationships to say, well, how does 14 connect then to this one? If we halved 6 to get to 3, in order to make it true and to make it the same, what has to happen to 14 in order to get there? Okay, so 6 times what number is the same as 3 times 14? You could also say, well, 3 times 14, what is that product? And 6 times what number gives us that answer? I want you to keep doing that by saying, how do the numbers on this side connect to the numbers on this side? And remember, we're trying to make all of these expressions true. That last one is a challenge. It says, Theo says she can find the answer to 8 times 90 by having the 8 and doubling the 90 again and again until she gets down to 1 times 720. Is she correct? I want you to think about the problem string that we did. So if we're starting with 8 times 90, how can we get to or could we get to 1 times 720? So double and halving. What one would we want to double? What one would we want to halve? I don't know about you, but I'm probably not going to want to keep having that bigger number. Probably going to want to keep having that smaller number in order to make it bigger. And then I can double the other, okay? If we started off with that, we'd say, well, 8 divided by 2 is 4. And doubling 90 is 180. So then we'd want to keep going on this path to see if I double, if I half, can I eventually get to 1 times 720? Is Theo correct?